Hi, I think you are doing well, right? So I think it's working. Okay. So today I want to tell you how you can add graphene in your model. So to enhance your to enhance the performance of your model. So this is a random model actually. I choose this model. So I use only graphene as the plasmonic material here. So yeah, I will add another thing. Oh, sorry, I will add a graphene uh, as another layer. Okay, so I just simulated this model from we can see from 530 to 630. Okay, so for refractive index 1.33. Okay, then I will collect the data for this model. So actually, for simulation, it takes some time. So I just simulate initially, then I will collect the data. So I will show you how the graphene changes the performance of the of the sensor actually. Okay, so let's collect the data. So I think you all know this all the setup of this thing, how you can collect the data. I think you already watched my previous video, so I think you all know how the sensor actually work. So okay, without further delay, we may work on that. So this is actually explorized light. Okay, so this is actually explorized light. Okay, let's find y. Okay, this is y polarized light. Okay. This one is y polarized light. Okay. So actually, in this model, x and y both polarized light will work. Actually, don't worry about it. So okay. So now for now, we may work on only x polarized light maybe. Okay. Okay. Where is the x polarized light? Okay, this one is x polarized light. Let's find out. Okay, sorry. Let's find out. Okay, this one is explorized light. Okay, for this one. Okay, so for 530 and 540, explorized light is uh presenting at the last one. Okay, so 30 and 40. Okay, so noise. I think you all know the process of data collecting. So just I am doing the same thing actually. Okay, so then I will collect data for other uh, wavelength. Okay, so for this wavelength, where is the explorer? Okay, this one is explorer's light. Okay, okay, no. So for refractive index, uh, for wavelength 550, the position is uh, third from the last. Okay, so this one. Okay, for 550, so say Control V. Okay, email. Okay, now we have to search for the okay, so this is for 517, 519, 600. So the arrow is getting small. It's not a problem actually. It's still expolarized. Okay, so don't worry about it. Okay, 620. Okay, fine. So all the expolarized light position is in the last position. Okay, so from 530, right? Sorry. No, from 500 actually. It's from actually uh, 530. Okay, sorry, I'm sorry. for that 530. Okay. So, this one. Okay. Okay. Now from 560 to 630. Okay. Test special transpose. Okay. Fine. So yeah, this is the maximum loss, and yeah, this is the graph maybe. Let me show you. So this is the graph of without graphene. Okay, for refractive index 1.33. 1.33. This model is random actually. Don't worry about it. Okay. So now we'll calculate. Now we'll add a graphene actually in this model. So for that, what we can do in the geometry? Okay, let's find out. Okay, this is for maybe okay. TG is for graphene. Sorry, is maybe about gold. Okay, so now we can duplicate this model. So for your model, just you have to watch the watch how I am adding graphene. Okay, then you are in your model you have to add in differently actually. Okay, so for this TG plus maybe for graphene the thickness could be 20 nanometer maybe. Okay, nanometer. Okay, okay, done. So this is actually gold, and this one is will be actually graphene. Okay, so now we have to we add the another layer. Actually, we add another layer. Now we have to add graphene. Actually, okay. Okay, so maybe this. Okay, don't worry about it now. Okay, silica, gold. Now we have to add graphene here. Okay. So how we can add graphene actually? So from materials, we can add material from library. Okay. So we have to add graphene, right? In optics, in organic material, in carbon, maybe we can find out graphene. Okay. This is actually graphene. Okay. It's working from 0.193 micrometer to 1.69 micrometer. It's maybe fine, okay? So we can add this graphene actually for our model, okay? We are adding graphene, okay? Nothing else, okay? So now double click here. So yeah, we got the graphene. So just we have to add this part, okay? So we are adding graphene on the top of the board actually right now. So in another case, maybe we can add graphene um, on the bottom of the gold actually. So we don't know the optimal thickness of graphene actually. We just add 20 nanometer thicker graphene. Okay, so maybe optimal graphene thickness maybe it could be 10 nanometer or 13 nanometer. We don't know actually. So for now, we just add uh, 20 nanometer graphene. So we'll see how 20 nanometer graphene changes the performance of our model. So let's run the model. Okay. So it will take some time. So you have to stay patient. Actually, I'm pausing the video right now. So I'll back after simulation is done. Okay. Don't worry about it. Okay. Simulation is done, right? So now what we can do, okay, simulation is done, right? So, okay, now you can see the arrow is very small, but it's okay. to know that. Okay, so yeah, what you can do? Um, I have to collect data, right? So from 530. Okay, so I don't know. Okay, so yeah. So the arrow is the direction of explorer is light as previously was this direction, right? Now it's in this direction, but it's okay. It's not a problem actually. Okay, so we have to find out the difference between adding graphene and before adding graphene and after adding graphene. Okay. So I think all the graph are in at the end of the effective mode, right? So okay, now evaluate it. You can evaluate it. So okay, so the position of the effective mode is at the end of this effective mode index. So this one, right? So we can copy data and we can paste it here. Yes, we can paste it here. We can just delete this one actually. We don't need this one right now. Okay, just copy paste this special transpose. Okay. So this is actually effective mode after after adding graphing. Okay. So confinement loss 1.33 for graphene. Okay. So I just copy this equation from here to here. So this one actually okay. This is actually wavelength. So this one okay. Now okay. So here you can see this is a big difference actually. Okay. This is a big difference. You can see the resonance wavelength is at 570, but we didn't find the resonance wavelength yet for 1.33. Let's see, it's increasing. Okay, so we didn't find the resonance wavelength yet. So we have to find out the resonance wavelength for 1.33. So this is the difference. Adding graphene before adding graphene and after adding graphene. Okay, so this is how you can add graphene actually. So maybe this the thickness of graphene we add here is not fine. Um, we may have to add a graphene um, on the bottom of the on the bottom of the um, gold layer. So to enhance to enhance the performance of our model. We don't know. Okay, so we have to find out the best combination. Okay, we have to find out the best combination. You may have to add a graphene on the bottom of the gold or on the top of the gold. Okay, so actually people actually add graphene to protect when they use actually copper or silver. So because as you know that copper and silver react with oxidant or environment actually, and they actually lost their sensing capability. So they actually add graphene on the top of the silver and or copper to protect them actually. Okay, for gold, you may not need actually graphene to add graphene to protect gold actually. For gold, you have to add graphene or titanium dioxide or other things to actually enhance the performance of the model. Okay, so now I can show you how you can add actually titanium dioxide. I already show you how you can add graphene. Okay, so for better okay for get the resonance wavelength actually you have to simulate more actually this model. Okay, so that's the thing. So in the next video I will show you how we can add titanium dioxide in the model. Okay, that is also very easy. So maybe I can show you right now. So without adding carbon, you can add actually titanium dioxide from material library. So you have to search just titanium dioxide here, nothing else. So if you want that, how you can add titanium dioxide or graphene from any equation, you may ask me. I'll show you how you can um, uh, uh, add titanium dioxide or graphene from equation. Okay, I'll show you. So if you want actually, if you need actually, if you don't need, so I don't want to just waste the time. Okay, so that's the thing. Okay, so we add the titanium dioxide. Why we add this titanium dioxide? There was other two options, right? So we add because the range of performance of this titanium dioxide is from 0.12 micrometer to 115 25 micrometers. So that's why. Okay, now we have to add titanium dioxide here. So this is the thing. So yeah, then you have to simulate the thing, and maybe for your case, you have to add titanium dioxide on the bottom of the plasmonic material or anywhere. Okay. So you can add titanium dioxide, graphene, gold, the combination of three layer actually. It may also enhance your the performance of your model. So I don't know, you can add it. Okay. Okay. So that's the thing. You can add multiple layer actually here to enhance the performance. Thank you everyone. So uh, watching my video, and if you like our video, you can just subscribe, like, comment, and share my videos. Thank you everyone.